Dear learners, I welcome you back to another session of Research Methodology for Tourism and Hospitality Management. Yesterday, we started with quantitative research methods and we were discussing upon the foundations of data analysis. This week is going to be very important for you because the topics which we will be covering is of utmost importance while you take up any dissertation or conduct analysis during your research period. We will be covering example wise the statistical test, and while we complete this particular week's course, you would be in a better position to understand the quantitative tools, especially with the help of statistical software which we will be using throughout these modules. So let us start. Today's module is divided into different segments. It starts with the scheme of analysis. Then we will cover briefly significance testing. I will demonstrate SPSS, a statistical software used by researchers and academicians worldwide. We will also see outlier, normality test and linearity, different assumptions which we have to clear before we go for major parametric test. So dear students, we have seen metric variables and non-metric variables. We also saw probability sampling and non-probability sampling. So when you collect the data and when you enter into the stage of analysis, we have to be very clear with what kind of statistical test that you will be applying. So this slide gives you an idea of what kind of statistical test that you can apply while you do your analysis. Let me explain one by one. You can see 4 columns. The first one is explaining the purpose of the analysis, and the second one explains the number of variables required for each statistical test, and the last 2 columns tell you what alternative that you can choose, whether parametric test or non-parametric test. So the first point here is, if you have only one categorical variable, example gender, male or female, or not specified. There are 3 levels in gender when we collect the data. In some cases we say yes or no answer, only 2 answers possible, dichotomous variable. So the first test which we find here is chi-square test for goodness of fit, and the purpose of conducting this test is, imagine you have a hypothesized value and that value you have taken from previous experiment or a literature, and you want to know the proportion of population of a sample, how it performs in the given circumstance. So for example, we have seen entrance examination results. So students qualify entrance examination with coaching or without coaching. So we want to know what proportion of the students qualify such entrance examination with the help of coaching. I will explain you it in the next module. We have taken an example, and while we go through the analysis process, you will come to know how you can come to a conclusion on this. Then the next phase is to explore relationships. When you have one categorical variable independent and one categorical variable dependent, you can use chi-square test for independence. So for example, here again gender, male, female, or you can take the students who qualify examinations, yes or no. You have 2 categorical variables, one is gender and the other one is the exam qualifying. Here the test which would be applying is chi-square test for independence, which falls under non-parametric category. Then exploring relationship with the metric variables. There are two continuous variables which you want to know the relationship. If one variable changes, how it will impact another variable. So correlation is a parametric test, Spearman rank correlation is the alternative. Imagine you want to predict or you want to understand the strength of independent variables on dependent variable. You may have two or more continuous independent variable which will be explaining one dependent variable. To understand this relationship, we will use multiple regression. Multiple regression is a parametric test. Then we can identify the difference between groups. There could be two groups or more than two groups. So here, when you want to know the difference between two groups and that is measured on a continuous variable. For example, again gender that measures a particular aspect that called IQ score. The parametric test option is independent sample t-test. What is the non-parametric option? The test is called Mann-Whitney U-test. The next is to test repeated measures. That means 2 point of time, that is before and after. So we have one categorical variable and one continuous variable. Paired sample t-test will work or Wilcoxon signed rank test will work. Another important parametric test is one-way ANOVA. Analysis of variance, that is ANOVA. Here we have groups which are more than two, that we call starting from 3 or more. Educational qualifications, or you can find yes, no, maybe, such kind of options as answers. That measures one continuous variable, that is a dependent variable. So this is done through the parametric test called one-way ANOVA. The alternative test is non-parametric test, that is Kruskal-Wallis test. So we have seen a number of tests, parametric and non-parametric. Let me once again review. Don't scare about these test names. The softwares make your life easy. You only need good data. We have heard about some test. The name of the test I just repeat. Chi-square test. Chi-square test for goodness of fit. Then we have seen testing the differences, that is through t-test or Kruskal-Wallis, Mann-Whitney, and testing the relationship, correlation, Spearman rank correlation as a non-parametric option. So this test, which would be easy to understand with the help of examples. Why I gave you this table? Before we go into the data analysis, we should have a clear understanding of what test should be useful in which conditions. Apart from this, there are a number of other statistical tools, advanced techniques which help you to understand the complexity of the data, relationships or differences. For example, if you want to test multiple dependent and multiple independent variables relationship. So this is called multivariate analysis. What we use is structural equation modeling. If you want to test the correlation of items in a particular list, we want to see the emerging factors, that is called factor analysis. We have exploratory factor analysis. We also have confirmatory factor analysis. Then we have cluster analysis to classify the objects, depends upon the homogeneity. Then conjoint analysis, discriminant analysis, logit regression, A number of statistical tests are there. Once again, my intention is not to scare you or move away your attention, because hearing this test you may feel it is very cumbersome or difficult. Having a basic idea will develop your interest to study statistics and also to better use these tools in your dissertation. When we go through the statistical analysis process, we often come across a value that is called p-value. Go through the slide which I have shared here. We get two types of errors when we do the analytical process. How these errors happen? The error is of understanding. How the researcher draw conclusion. While drawing conclusion, if the researcher is falsely rejecting a hypothesis or accepting a hypothesis, it is given as type 1 error and a type 2 error. In a lighter note, let me quote the statement given by Blumberg. I quote this from the book of Saunders on business research methods. You can find type 1 error and type 2 error with the help of this example. The first one is type 1 error, in which imagine a innocent person is convicted and sentenced to jail. See, we know that in our society there are several incidents happen, but by mistake the judge sentences the individual. Maybe we are not going into the details of the punishment or the judgment. I am just taking an example. It is called type 1 error. Type 2 error refers to accepting the null hypothesis even though it is wrong. So what is the example given here? The example is a guilty fellow, a person who is a convict, is set free. So to see this, we use a particular term, the probability value, that is the p-value. We connect it with the percentage, that is 95% of confidence, or is a p-value with 0.05. We always use this p-value with higher or lower. When we analyze the result, we can get this value. So to reduce type 1 error, we can use the significance level at 0.01, that is p-value is less than 0.01. So I hope you got the clarity. That is, when we are testing two variables which are actually not related, but we come to a conclusion that they are related. And the second case is the type 2 error. We come to a conclusion that two variables are unrelated, but in reality they are related. Testing the probability of a relationship between variables, whether it is by just a chance, and if there were no difference in the population from which the sample was drawn. So first let us say we have a population, we draw a sample, we conduct a test, and we want to know whether two variables are related. So a statistically significant relationship means what? The p-value less than 0.05 when you complete the test. So the chance of entering into a wrong conclusion, that is type 1 error, that is just with the chance alone is very low. That is, we reject the null hypothesis if p-value found to be less than 0.05 or 0.01. I use the quote of Saunders. Probability of 0.05 means that the probability of test result occurring by chance alone, if there was really no difference in the population from which the sample is drawn, that is out of 100, we will have a demonstration of SPSS now. SPSS is a software which we widely use in researches, statistical package for social sciences, and it contains numerous options to conduct the test. I will quickly demonstrate you how it functions. In your post-graduation or PhD, learning SPSS is important, or any other software which can help you in data analysis. I found SPSS is quite useful in our research. The window of data opens exactly like what we have Excel. When you use MS Excel, it is a spreadsheet. We can enter values. So it has two windows. One is data view and the second one is variable view. What we do first, we open variable view. Now look at the titles. Here we have to give the right meaning. We have to define the variable, what type of variable it is, whether it is a text or whether it is a numerical variable, whether it has a decimal values. You can give a label and you can assign value. I will quickly operate it for your knowledge. See, at first we have to define the variable. I entered the variable name age. Now I have to give type. The type of the variable is numeric, and we enter age like years, 31, 30, 20. We never enter age like 20.5, 30.5 like that. The width means the number. Age we can have maximum 3. See, we can reduce it into 3 or 2, depends upon you. We don't have to indicate any decimals. As a practice, we avoid, keep at 0. Label, I write here age of the respondent. Now, I am not giving any value here, let it be as it is. I am adding another gender. Here, gender is again considered here as a numeric value. It doesn't need any, that would be enough. 2 or 3 would be sufficient. No decimals required. Here I write gender of the respondent. I am giving a value definition here. Here I will code 1 for male, 2 for female, 3 for others, which include third gender or those who are not specified. See, this way we give definition. See, it would be helpful when you do the analysis. Now I open here the data view. See, you can find age. I enter the data. Imagine I collected the data from 5 people. The first individual is 20 years. Second individual is 34 years. Third individual is 25 years. Fourth individual is 18 years. And fifth person is 50 years. Now gender, I have already coded the data. 1 for male, 2 for female, third gender not disclosed, 1, 2. See, this way we will have the data entered in this sheet, and then you can use different drop-in menus to do the analysis. In the coming sessions we have to use this. So SPSS, or you can use Jamovi, or you can use other tools like Python, R, but in Python and R coding. Otherwise SPSS or Jamovi, where without coding you can do your work. Herewith I stop the demonstration of SPSS and we will go back to the presentation again. For your quick attention, I would like to mention that one of the frequent problems I find, the respondent at times they don't pay attention to the entire questionnaire. They are in a hurry. Just imagine, I have given the 5 sentences here. You are conducting a study and I have given here 4 variables. So the respondent can give answers, if they are honest, they will read the lines, and if they have time again, they will read the line by line and give the correct response. If they are in a hurry or they don't have interest, either they can put all values 1 or they can put all values 5. How dangerous it is in data analysis. I will explain you when we study normality or outlier. So it is very important to understand that a genuine data reflect a good analytical result. So let us proceed to the next slide. The first one here we have to study is what is an outlier in the data. Outlier is an extreme value that is different from others, that influences our analysis in a bigger way. So it would be a higher value or it could be a lower value. Let me explain this with an example so that it will be clear to you. See, you find the example here, a question, age group of students in a class. I wanted to check. So the data I entered is like this. Age you can find in column 3, that is 18 years, 19 years, like that it goes. And can you see one particular respondent's age, 5. What is the age here? 30 years. So do you think the whole value otherwise it range from 18, 19, 20 like that. And when you see here one individual student, his or her age is 30 years. So you know how it is going to impact the study. I have shown a diagram here, and in this diagram you can find it is called box plot. It appears like a box, and you have seen some values 5 and 18. 5 indicates 5, it is mentioned with a star, asterisk. So that is an extreme value from the rest of the values. Number 2, 18, the respondent 18 is 15 years old. 15 years old studying a undergraduate program, surprising, right? So let us say when we make a box plot is a mechanism to understand the outlier. What is outlier again? Outlier is an extreme value. It can be low or it can be high. Here we have two values. One is a low value, that is 15. The graph clearly says you have to check the ID number 18, which is showing by a circle, but ID number 5, which is shown by an asterisk, that is more dangerous. Box plot presents the interquartile range. So the total value that you have is divided into 4. The two end is called a whisker. You have seen cat, the mustache like whisker, it is called whisker plot otherwise. So the two whisker is at the bottom level, it is minimum value, and the other end it is maximum value. The box is divided with a line, that is the median value. So the box end, that is starting quartile 1 and the top quartile 3. So in between the median value falls. So when you look the data with a box plot, check the asterisk mark, star mark. Go to that ID, either you remove that item from the analysis, else it will impact your study. The circles which you do not have to remove, if your data size is large, it will not impact your study much. So what is the takeaway point? The box plot is a useful tool to test the outlier in the data. If there is asterisk mark in the box plot, you have to remember that the data contains outliers. The circle also indicate outlier, but it may not impact your data in that extent. How outlier happens? See, we are all human beings. When we have to enter large number of data, there is a possibility of human error. So instead of say 18, I made 80, or 20, I made 2. So these are the errors possible. So keep your data set near to you while you do the data cleaning process. Checking outlier is very important while you process your data for further analysis. So according to Hare is one of the highly referred author to check the statistical tools used in research. So any observation which are less than 80. That means your study is restricted with only 80 sample size or less than that 80. When you do the standardization of score, if the standardized score is more than 2.5, that indicates outlier. In the first I told you about box plot, and here there is another mechanism. What you can do? You can calculate the Z value. When you calculate the standardized score, if the Z score is 2.5 or greater, you can mark that value and check the ID, and if required, remove the item from your response set. If the sample size is more than 80, if the Z score is more than 4, you can identify that scores are outliers. So, in practice, we identify any standard deviation between 2.5 or 4 are outliers. In the first example, we saw box plot. Second example, we saw the standardized value, how you can check. Or another mechanism is scatter plot. If it is a bivariate variable, here you can see distance and amount as an example. Imagine you reach college or the university by using auto rickshaw or bus, and the amount that you pay is given as an example here. See, when you look at the amount, it ranges between 25, 35, 40 like that. But check, there is one amount which costs 100 rupees. See, that is shown in the x axis, you find the distance, y axis you find the amount. And look at the distance 3 kilometers, there is one respondent pay 100 rupees. So, does it mean outlier? Yes. We can use scatter plot for bivariate variables. First, we have a single variable, that is univariate. Second example, we saw bivariate variables, and the third example here we see multivariate. See, there are a number of variables that we study in our analysis. Any analysis which contains more than 2 variables, that we can consider as multivariate. And how to calculate Mahalanobis d square value? In regression, we find the Mahalanobis distance. So, when you calculate Mahalanobis d square value, it clearly says the values which are more than certain limits. There is a clear threshold limit. If you have 3 independent variables, what would be the limit? If it is 4, so there is a clear definition. Look at this table. Here you can find the distance covered, that is 300 rupees one individual is paying, and the Mahalanobis distance square, that is 18.96. Here we have 2 independent variables, that is amount is the dependent variable, distance and bonus, these are independent variables. So, when you have 2 independent variables, the Mahalanobis distance d square should be less than 13.82. If we have 3 independent variables, it can be 16.27. If it is 4, 18. If it is 5 independent variable, 20, like that it goes. So, Mahalanobis test d square value is a mechanism to identify outliers in multivariate data. Learners, we have seen outliers in detail. If there is a presence of outlier, remember that will impact your result. So, it is important to identify outlier and treat it accordingly. Let us see the next one. This is called normality of data. When we collect data, I told you already, some people may always put 5 as the best value. They do not want to displease you. By chance or possibilities are there that the respondent give higher score, though such scores are not appropriate against that statements. Testing normality is an important part of preparing your data for further analysis. you can see two terms, one is kurtosis and the second one is skewness. So here the shape of the curve that matters. How you assess the shape of the curve? If your data is normally distributed, it forms a bell shape, and the kurtosis and skewness value will be within the threshold limit. There are two chances. One is the kurtosis that can be flat to the axis, or it can be raised further, that we call the peakedness of flatness of the distribution. Peakedness or flatness of distribution, that is termed as platykurtic or leptokurtic. If the distribution is flatly distributed, it is negative values, the result will be platykurtic. If it is positive, that means the curve will be peaked. You can find the extreme right. So what would be a normal distribution display in the first one? How to check this? And this is not the only case. There is also skewness. You have to check the skewness of the data. Here we can find a box plot, and the first one I have shown a normally distributed data where the minimum and Q1 the data will be around 25%, and from Q1 to median it will be 25%, from median to Q3 that will be 25%, the maximum value and Q3 that would be divided as 25%. So it forms exactly a bell shape. A skewed data, when the peakedness of the curve it goes to the left, that we can say positively skewed, or other side it is negatively skewed. So how we identify the data is normally distributed? The best way to identify normality is z-score. So the calculated value will tell you whether this data is normally distributed or not. See, I have 20 students in my class. Their semester results are measured as CGPA score. The score which is given, that range from here 7, 8, like that. 20 students score I have placed here. So when you calculate the skewness, it goes 0.01, and kurtosis, that is negative 0.119. So two values that you have to check here is, one is skewness and the second one is kurtosis. How we can identify? If the sample size is small, you can use Shapiro-Wilk, that p-value score. The value is more than 0.05. I have highlighted with yellow color. It indicates that your data is normally distributed. Exclusively, there are some values given here. The sample size less than 50, normality is going to have a major issue. If the sample size is more than 200, that effect will be reduced. When you test the data for normality, you can check the Shapiro-Wilk, the p-value score, or skewness and kurtosis. The skewness and kurtosis value you can check against their critical Z value too. The next aspect that we will be covering here is linearity. If you have metric variables and if you want to check the correlation, the measure of association between two variables, it should be normally falling in a line close to a line, diagonal line in between x and y axis. So linearity means straight line. So let us see, we have two variables, that is x and y. When we create a scatter plot and when we check it with a diagonal line, that how the data is linear, you can understand here all the observations which is falling near to the line, and if it is scattered, It will not be like a linear distribution. I have tested here one CGPA score and second their IQ score. There are certain values which are very close, that is the student scored 80, their CGPA score is 6, the student score 100, their CGPA score is 6, 110. So, some values which are away from the diagonal value, that indicates how distant it is. In regression and correlation results, this matters a lot. So, checking linearity is one of the assumptions for parametric tests like correlation, regression, multiple regression, and other tests, normal distribution or outliers, testing outliers, scomuscedasticity. So, these terms we will find frequently when we go with statistical analysis. So, dear students, this session was little exhaustive for all of you, but remember, we are slowly entering into a very serious part of data analysis. I have demonstrated you different elements which is very important for doing quantitative data analysis. At first, I started with preparing the scheme of analysis, then indicate how many variables that you have, which test would be appropriate under what conditions, under non-parametric and parametric, what are the test options available. And in the second part, we have seen SPSS, how to operate SPSS. In a brief way, we discussed how we can enter the data, but hands-on experiment is very important. You can use Excel sheet even to enter the data. Open access softwares like Jamovi will be helping you to do the analysis at your end. Then we checked three major assumptions that we have to test with the data. That starts with outlier. Remember, outliers influence your result. The distinct value from the normal data that we collect, that is called outlier. We have seen how to check the presence of outlier in your data: univariate, bivariate and multivariate. There are different methods. At the second level, we have seen how to check normality of the data. The data should be normally distributed, that is the assumption, but in many cases it is not possible, because when we go to the field, we get the original data, and when we check the normality of the data, many occasions that violates, the principle of normality is violated. So, then we find linearity. Linearity is checked when we do correlation or regression or finding association between two or more multiple metric variables. I am sure that you may have several doubts. Refer appropriate books, do hands-on experiment. If you have any further doubts, come back to me. I hope you had a good learning session today. Thank you.